In this lecture, we will see what is KHN filter and what are the motivations behind KHN filter. What is KHN filter? KHN is a universal filter. KHN is an universal filter. Universal means it can be used for all pass. It can be used for low pass. Every filter can be implemented using KHN filter. And what is the full form of KHN? High pass. Every function. And what is the full form of KHN? KHN stands for Kervin Hulsman Newcomb. Okay. And what is the motivation? Because we require sometimes we require low pass, sometimes we require high pass, band reject, notch. So this is a universal filter by which we can use any implementation. Okay. So we for KHN we should know the transfer function of every filter. So we know transfer function of high pass. Transfer function of high pass filter we have seen in the previous lecture. If the output of high pass is VHP and input is Vin, then it is equal to AF S square, means R square C square S square upon R square C square S square plus R C S into alpha plus 1. We can write it as AF S square upon S square plus 1 upon RC into alpha S plus 1 upon R square C square. Now I am writing AF as K. I am writing AF as K S square upon S square plus 1 upon RC. 1 upon RC omega naught pole frequency or cutoff frequency. Alpha, we know alpha is equal to 1 by Q, quality factor, into S plus omega naught square. So this is a high pass transfer function. Here omega naught is pole frequency and sometimes it is known as cutoff frequency, and Q is a quality factor. And it is equal to 1 by alpha. Alpha is damping coefficient. Can we write it as a VHP by taking simple LCM? VHP S square plus omega naught by Q S plus omega naught square is equal to K times Vin into S square. We may write by taking simple LCM. Now VHP S square is equal to K Vin S square minus omega naught by Q into S minus omega naught square into VHP. Here VHP is also there, also exists. So VHP is equal to K times Vin minus VHP omega naught by q into 1 by s minus omega naught square by s square into vhp. Suppose this is equation number 1. Now we should know what is integrator. What is integrator? So we know integrator. We know integrator. Integrator. If this is R and this is C, this is V. This is C, and this is V naught. This is input voltage V in. So what is the output voltage? We can calculate by simple S transformation. So Laplace transform of capacitor is 1 by Cs. Okay. This is output. This is input. Now this is virtual ground. This is if it is at 0 volt, then it is also at 0 volt using virtual ground. So if current I1 is flowing in this branch and in this branch I2, then KCL at X node, we get I1 is equal to I2. What is the value of I1? V in minus 0 upon R is equal to 0 minus V naught upon 1 by Cs. And we get V naught upon V in is equal to minus 1 upon RCS. And we may write 1 upon RC minus omega naught upon S. It means the transfer function of integrator is minus omega naught by S. Okay. So in next lecture we will connect this to the implementation of KHN filter. Thank you.